For the last installment of this introductory series of SynthEyes videos, I'd love to use a common example of something I've done for years and now often see requested by others for 3D tracking. For our 3D tracking to be useful, we have to export our work to other software. But before we start clicking exporter names, we should make sure our actual tracking is good. So we do QC. So let's look at some of the steps we need to prove that the 3D tracking that we did is perfect. Doing QC will provide that proof. Right. The first thing we're going to do is render a preview movie using our proxy geometry and our 3D camera track. It's going to show that the match move we did will make any CGI added later lock to the motion picture photography. We want to render the wireframe over black so we can then slap comp it over the footage and check the tracking. And because we want to mimic what would happen in a typical VFX pipeline, we need to talk about lens distortion again. First, let me show you something that might be a gotcha. You switch to the lens room by clicking on its name, right? Right. Well, what if we wanted to switch back to the 3D room, but leave the lens room's viewport layout, camera? Instead of clicking on the room name, 3D, click on its icon. Now we are in the 3D room. The controls on the left changed to the 3D room controls, but we kept the lens room's viewport layout, camera. This works for all the rooms. Now we're in the summary room, but we haven't changed our viewport layout, or the rotomasking room, or the features room, trackers room, planar, GOH track, graphs. Graphs is a little different. Lens, solver, phases, coordinates, 3D, and lights. Now, let's go through the rooms again, but not clicking on the icons, let's click on the names. So there's a summary room, same camera layout, rotomasking, camera layout, features is also the camera layout, trackers, camera layout, planar tracking, camera layout. So all of those by default use the camera layout right here. GOH track, that uses a perspective view, so you saw the layout change there. If we go to the graphs room, well, that's an entirely different thing. It changes this whole viewport to the graphs viewport, which you can see if you click on that right there. And you'll see the graph editor is now this whole viewport. Lens room, back to the camera layout. Solver room has its own layout, the solver output layout. Phases uses the phases room layout. We'll talk about that maybe someday. Coordinates uses the constrained points layout. And 3D uses the custom one layout. Because we made this custom one layout a while ago, let's switch it to two perspectives. And lights uses the quad view. So camera, front, top, and left. So if you ever see this happen by accident, now you know why. Better still, now you know how to do it on purpose, which can be very useful. Whenever you switch rooms, feel free to use whatever layout you want. You have total control over your UI layouts. Let's go back to our two perspectives layout. We're going to go back to the 3D room, clicking on the icon, and let's go to two perspectives. Beautiful. Let's get back to the lens room by clicking on its name. Let's get back to lens distortion and talk about the lens room's lens grid. It's there in the camera viewport, but it's a little hard to see. To make it easier to see, let's bring up the floating hierarchy view. First, let's hide our trackers and our geometry and turn off show image. First thing we're going to do is hide the trackers. There's a little eye symbol. Now the trackers are hidden. That cylinder we made a long time ago to establish the scale of our scene, it's still in the scene. It's just hidden. But let's also hide our track mesh 01, the proxy geometry we built. So that's hidden. And we're going to turn off show image. Let's open up the lens distortion control panel by clicking more. The more button is right here next to calc distortion. The numbers already there are the lens distortion values SynthEyes calculated back when we solved the scene. Now let's look at how twiddling the numbers changes the lens grid. So we're going to twiddle a little bit, and every time I'm going to undo. So just to see, C2 is like quadratic distortion. So that's just an overall big distortion. So there we go. I'm going to undo that. And then I'm going to do U2, which is an interesting kind of distortion. It's almost like the distortion is rotating around the up-down axis of the screen. Undo that. V2, same thing around the x-axis. Undo. And then C4 is distorting only the edges, the corners, really. Like as we extend out toward the corners of the image, that's what that controls. U4 does the same thing on the corners that U2 did. So U2 was the whole thing, but U4 is just the corner areas. And V4 is going to be the same way as V2. There we go. All right, undo that. So these are our original calculations. I'd say well over 99% of the time, the calculated distortion values from SynthEyes are better than using photographed lens grids. By the way, the same is true of the SynthEyes calculated focal lengths. Those calculations will nearly always be more accurate than the camera reports from onset, if the tracking is good. Now that we've taken a look at what the distortion numbers do to the lens grid in the viewport, let's turn everything back on. So again, all of the values in the lens distortion controls are what SynthEyes calculated, which reminds us the photography has lens distortion. And when we remove the lens distortion, the image displayed throughout SynthEyes is going to warp. Let's open the image preprocessor. That's under the shot menu, image preprocessor, or just P on your keyboard. Go to the advanced lens tab and switch the lens model to standard radial fourth order, because that's the lens model we used to solve this shot. Take a look at the coefficients in the solver controls window and compare them to the coefficients in the image preprocessor window. These are the same coefficients, and they warp the image in the image preprocessor the same way they warp the lens grid in the lens room. Note that barrel distortion brings in the corners, while pincushion distortion pushes the corners of the image outside the frame. To see what got pushed outside the frame because of the pincushion distortion we just made up, we need to go to the cropping tab. Cropping is a bit of a misnomer here. When we adjust these cropping values, we're actually making our image canvas bigger. Like you might increase the canvas size in apps like Photoshop. And we do this so when we undistort the photography, we have a canvas big enough to hold all the original image. We'll need to deal with all these things when we remove the lens distortion, because we want to preserve all the photography when we undistort. So we need the computed distortion values in the solver controls window to be moved to the image preprocessor. And we need to compute those cropping values to give us a bigger canvas. And we need other adjustments to make sure all our tracks stay locked to the features in the undistorted photography. Doing all that by hand would be a nightmare, but don't panic. SynthEyes is going to help us out. All right, so I'm going to hit cancel here, and it's going to get rid of all these values. So there we go, cancel, good. The lens workflow button is going to do all that work for us. So let's click the lens workflow button. We want to use the Redistorted 2 option. That means we're going to undistort our image, and when we export to compositing, Nuke, Fusion, After Effects, whatever, we're going to export both the means of undistorting and redistorting the photography. Undistorted 1 assumes you want to bake the undistortion into your photography and use that for the final work. This is highly destructive and not recommended. There may be other reasons you might want to permanently undistort your images, but when compositing, you typically want Redistorted too. We'll leave all the other values at their defaults and click OK. All the coefficients in the radial fourth solver control window are now 0. Now bring up the image preprocessor again and go to the advanced lens tab. All right, so the advanced lens tab. Oh, look at that. Now all the lens coefficients here have numbers. These are the values for undistorting the image that were derived from the lens distortion SynthEyes calculated when we originally solved the track. And the numbers in the cropping tab have changed. All these controls work together to undistort the image. All of this is done automatically behind the scenes to remove the lens distortion from the image and prep the project for export. By the way, that's why the numbers in the solver controls window are now all zeroed out. They are now represented here in the image preprocessor. Now that the lens distortion is removed, we're ready to render our preview at that larger canvas size. So back to the 3D room. There are many ways in SynthEyes to render a preview over a black background. But here's my favorite way. We need to go to the Preferences again under Edit, Edit Preferences. We're going to change one of our user interface colors. You get a lot of control over the colors of the user interface. For now, we're just going to change Persp Background. That's the background color for all our 3D perspective viewports. And we'll make it black. In our locked 3D camera viewport, let's turn off Show Image in the View toolbar. Now we see both 3D viewport backgrounds are black. This user preference is a global change for all perspective viewports. It's just a user interface preference. And let's make sure Occluded Wireframes is turned on in our locked camera perspective viewport. That's a right-click menu item, View Occluded Wireframes. So it doesn't occlude the trackers, you can see those through the geometry, but it does occlude the geometry, so that's nice. Now, let's render this viewport as a preview. We can either right-click in the viewport and select Preview Movie, or we can click Render in the mouse toolbar. That brings up the Preview Movie settings window. The first thing we want to do is tell SynthEyes where we want to save our preview. So we're going to go to QC Process, Media, Renders, and we need to give our preview movie a name. Preview renders can be image sequences or movie files. I'm going to save our preview as a QuickTime movie. Let's check the compression settings. I'm saving this as ProRes 422 LT. We want our wireframe rendered over a clean black background. So let's make sure Show All Viewport Items, Show Grid, Alpha Included, and Depth Included are all off. Because this isn't an anamorphic shot, square pixel output doesn't matter. If you turn it off, it won't make a difference. It does make a difference if you're working with anamorphic footage. But that's a whole different tutorial. RGB included does matter. That's your RGB image data. So let's make sure that is on. As always, the balloon help will give you more information for all these checkboxes. Let's set anti-aliasing and motion blur. Typically this will be on none, but as a default. We'll set that to Mobler Max. Shutter angle is an anachronism from the days of motion picture film cameras. And they're circular spinning shutters that had a blade you could open or close for longer or shorter exposure times. A shutter angle of 180 degrees tells SynthEyes that frame will be captured over 1/48th of a second if we're shooting at 24 frames per second. That's half the time a frame of film would sit in the film gate. Look, I promise you, I'm not trying to turn this into a technical film history and math lesson, but the higher this number, the longer your motion blur streaks. The default 180 degrees is great, so let's move on to phase. Phase is at what point in time the virtual shutter of your camera should start to open during its 1/24th of a second existence in time. Let's just leave this at the default too. We don't want frame numbers burned into our preview by SynthEyes because we don't want to render frame numbers in our wireframe preview after we've removed the lens distortion. We'll be redistorting this wireframe render later, and that will redistort any frame numbers that SynthEyes added at this step. And that would be weird looking. Now is not the time to add frame numbers. So let's make sure frame numbers is off. So yeah, that's off, off, off. Now we just have to click start. You could export the SynthEyes scene to the 3D application in your pipeline and render this preview there. But when it comes to just rendering wireframe previews, SynthEyes is perfectly adequate standing in for whatever 3D animation app you have in your workflow. Beautiful. Let's open up info on our QuickTime preview. That larger resolution is the size of our expanded canvas for our undistorted footage. This bigger size is enough to hold all the image of the original photography after we removed the lens distortion. Remember, that lens distortion was just caused by the lens of the camera, and our wireframe preview is rendered at the bigger, undistorted size with no lens distortion. So we need to put that lens distortion of the original photography onto our wireframe preview, which is standing in for any CGI that could be added to the shot later. I'm going to redistort our wireframe preview in BlackMagic Designs Fusion. It's a node-based compositing application that's very similar to Nuke. All the compositing app exporters will have nodes or layers similar to what I'm going to show you here. So to export, we'll go to File, Export, Fusion, Fusion Composition. Then we'll tell SynthEyes where we want to save our Fusion export. QC Process, Project Files, SynthEyes, Output, Fusion. This may be automated in your company's pipeline. You may have your own folder structure. Whatever the case, I guess what I'm saying is everybody's pipeline is different. Once we do that and verify our file name, let's click Save. If you have Fusion and you wanted to follow along at home, just to make sure we're starting from the same place, let's click the Defaults button in the Fusion Composition Settings window. I, of course, have Fusion installed on this computer, so I'm going to check the box for Open the exported file. That will just launch Fusion automatically. We're going to leave the rest of these settings at their defaults and just click OK. Fusion opens, and now we see our exported track. I'm going to talk about it a little. I'll send the top left node to viewer 1. And then I'm going to make this a single viewer. I'm going to Command F to fit. This isn't a Fusion tutorial, but I'm going to show you a few things in Fusion to just get oriented to what we're trying to do here. The controls in Fusion are going to be very similar to Nuke, and the ideas and theories we'll be going over will apply to all compositing applications. Back to the top left node. This is the loader for the original footage that we tracked. All right, so that's our original footage. The node just below increases our canvas size and crops the image to accommodate the larger space of the undistorted image, just like the crop tab in the image preprocessor in SynthEyes. So these cropping values are going to be the same as the cropping values done here, but you'll see in a second. The bottom left node undistorts our image, just like the SynthEyes image preprocessor did after we ran the lens workflow. So let's compare the image in Fusion to the image in SynthEyes. I'm going to select this and I'm going to send that up. There we go. So this gap over here, that gap at the top, the gap on the left and the bottom matches these. The only difference being that in Fusion, the gaps are just transparent. There's nothing there. So that's why you see the checkerboard. The node right in the center, named SynthEyes Scene, is Fusion's 3D environment. in which we can see our camera track and the proxy geometry we built. You could even add 2D elements or more 3D geometry to this 3D space when doing the final comp, and they would be locked right to the space of your 3D camera track. Fusion has its own node to render everything, and that's the Cam1 renderer node. This is Fusion's render of all the solved 3D tracker locators and the mesh we built all over the undistorted background. Now, what I'm about to say may come as a surprise. All the nodes we just looked at, we don't need any of those nodes for what we're doing here today. Just adding the lens distortion back to our wireframe render. We only need the loader node for our original footage in the top left, and the 2 nodes on the bottom right, the Cam1 Redist node and the Cam1 Cropdown node. Those are the nodes that will redistort our wireframe. So I'm going to make copies of those nodes and disable all the others. What we do need is the preview render we just made in SynthEyes of our wireframe on black background. So let's drag it from our files right into Fusion, and let's send it to viewer 1. And now we're going to play for a bit. Good. And let's check that the resolution of our wireframe is the same as the undistort node. Checking these details is all just part of the QC process. We just want to double check everything. So in Fusion here, this is our original footage. This is our wireframe. And we want to make sure that the undistort node, which is down here, that undistort node is 4096 by 2304. Let me go to our movie. That is 4096 by 2304. This movie is our CGI Stand-in. Now we'll redistort our wireframe render and slap comp it over our original footage. So what we want is this. I want that to go into the redistorter, and then we want it to be cropped down. We're going to put that on top of this with a merge node. So we want that to go into the foreground of that. And then we're going to change this to screen. At this point in your own workflow, you can add shot name text and frame counters right in the slap comp. But this render speed isn't that great. It's because of the node that's redistorting our wireframe. Let me show you another way to deal with lens distortion in compositing. One that renders a bit faster. ST maps. First, let's just delete that last Fusion comp export. When we've already exported a shot in a particular file format, SynthEyes remembers and makes that exporter easy to select. File, export, but you see Fusion composition is right here because we just exported it to Fusion. So I'm going to click on that. So we're going to click save on this. This time in the export settings, we'll turn off use lens distort node and just click OK. Now when our scene gets exported, it won't be using those slow distortion nodes. It will generate ST maps. The ST maps will do the distortion by pushing around all the pixels in our image using the red and green channels. So first I'm gonna show you the ST map. There's the ST map. Here we see our gap around the edge. This is for undistortion, remember. That's the original footage. And now let's look at the undistorted footage. There you go. Original footage, undistorted footage. And again, remember, the original footage, 3840 by 2160, and the undistorter is 4096 by 2304. And now that we're looking at this undistorted image, let's just tap the space bar. Oh yeah, that renders considerably faster. So why don't we just use ST maps all the time? If you have changing distortion due to lens breathe, and you're working in 8K, you won't have to push an image sequence of 1,000 8K 32-bit ST maps over your network. With the distortion node, the coefficients can just be animated. So you have options. SynthEyes can do either very easily. So when we look at our original footage and then compare that to the undistorted version, now you know what's happening. Let's render out our redistorted wireframe and finish our QC. We're going to wire this all up again. I'm going to copy these 2 nodes that we need, paste those there. I'm going to drag my wireframe preview in here. I'm going to put that down there. I'm going to drag this over and I'm going to add a saver. I'm just going to copy the file path from the Wireframe movie loader and paste that into the Redistorted Wireframe movie saver, adding _RD for Redistorted. I have Fusion set up to render out ProRes 422 LT by default, and in the Format tab, let's make sure our frame rate matches the footage we tracked. The original footage was shot at 23.976 frames per second. We are rendering this at 24 frames per second, so we don't want that. We want 23.976. Now we just have to click the render button. Now let's go to DaVinci Resolve and set up our slap comp. And we'll do some more QC. So let's check a few things. I've already made a timeline in Resolve with our original footage. So let's drag our Redistorted wireframe preview movie right onto that timeline. I've rearranged my column layout in my media pool so I can explain this a bit faster. Let's make sure the resolution of our Redistorted wireframe preview matches the original footage. And you can see that in the media pool here very easily. And they're both 3840 by 2160. Let's make sure the frame counts match. This original footage, 706 frames. Our Redistorted preview, 706 frames. Now let's check the frame rates. Okay, so we have frames per second, 23.976, 23.976. Great. Those all match. Next, let's set our composite mode for our Redistorted wireframe movie to add. Video composite mode to add. Now would be the time to add a frame counter. So let's add a frame counter and a shot name. I'm going to put a frame counter on here. Neat. Great. And let's do a shot name because sure, why not? And what is our shot name? Paste. Let's just do a little cleanup to make this nicer looking. And now let's just tap play on the spacebar to see how this looks. This is just one more QC opportunity to ensure that our proxy geometry sticks to the photography, that our track is good. So let's scrutinize. What I do, scrutinizing a track, is I'll break the frame up visually into quadrants. So anyway, I'll watch a video over and over and over many times and make sure nothing is slipping. And then once that's done, I consider the scrutinization to be complete. Now, all that remains in this step is rendering our QC movie. I'm going to add an _QC to this file name. So I go to the deliver room. I'm going to do a little browse action. And I'm going to select my original footage, my original QC render that was undistorted, and I'm going to add an _QC to this name. And we're going to render this out as another QuickTime movie, but this time H.264. You could render it out as an MP4 version of H.264, doesn't matter. So everything else I'm going to leave in its default state. We don't want to export audio, so let's make sure that's off. It is off, that's good. And the file name right here is good. So that's done. I'm going to add that to the render queue and I'm going to render it. Ta-da! Perfect. And let's pull up that QC movie. What this render will prove is that when anyone renders out 3D animation using your match moved camera, your track, when their render is redistorted, it will lock to the original photography, just like your wireframe movie that was standing in for any CGI. The track looks great. Now let's prep the rest of our delivery, starting with rendering an image sequence of our undistorted footage. For that, we'll go to the image preprocessor and go to the output tab. Then we'll click the Save Sequence button. In this new window, again, We'll make sure RGB included is checked. We'll turn off frame number time burn-in and no alpha or meshes included. Now we'll click the 3 dots to set the file name. Okay, we're going to change the format to JPEG sequence, which is where it is, which is where I normally have it. That's what most people ask for. Send us a sequence of JPEGs that is undistorted. We'll save this image sequence in renders undistorted. In the name, we'll add trailing digits with a start number to tell SynthEyes how to number our frames. I'll add .1001 and then click Save. That just tells SynthEyes our image sequence should start at frame 1001. Remember compression settings when we rendered our wireframe preview? Well, here's that button again. Because we're saving JPEG images, let's click it. Yeah, 85 quality for an undistorted JPEG sequence should be fine. Then we just have to click Start. SynthEyes will now blast out your undistorted JPEGs. You can use these as background images for your 3D animation pipeline, and they will tell you at what resolution you should be rendering your CG elements. But the exporter to Maya, Houdini, Blender, all the exporters will set up that undistorted overscan resolution for you automatically. When the render is done, click OK to close the image preprocessor. All right, so let's go to undistorted and look at, oh yeah, there we go. If you're exporting to other applications, as is typical, this would be a good time to do those exports. As I often repeat, SynthEyes exports to so many different applications that it's just too much to cover every exporter here. So we're going to choose the Maya export. File, Export, Maya ASCII updated. And we're going to go to Maya and we're going to hit Save. Just remember that the balloon help in all the export windows on all the buttons and checkboxes is there for you. I have a closing note about the Blender exporter. I love Blender. However, it being open source and constantly under construction, keeping the exporter updated is kind of tricky. There have been several versions of Blender that completely changed the rules and just wouldn't import the Python exports that SynthEyes was writing. So, it's often helpful to keep a previous version of Blender around. When an export fails on the latest version of Blender, just load the export in an older version, save the Blender scene file, then just reload your scene in the latest version. And when that doesn't work, you may need to load the Python export script into Blender and run it manually to see where the script fails. I just had this happen. Let's export. We're going to export to Blender. File, Export, Blender, Python. We're going to put in the Blender folder, hit Save. So the Blender application, if you've got multiple versions of Blender in different folders in your applications folder, you can specify a specific version of Blender or a specific file path to that version of Blender. So for me, it's applications, Blender Foundation, Blender 3.2 / Blender app. So that's the version of Blender I'm going to write this out to, and that SynthEyes is going to automatically run. And now you'll see we're in Blender 3.2.0. And then we would just save this scene file, save as. I could put that in project files, SynthEyes, output, Blender, and then just save this with the correct file name, which would be Command V, and I'm going to hit save as. Now I can relaunch that file. I'm now opening that Blender scene file, but this time this is going into Blender 4.1.0 alpha. So that's how you can get files to work in later versions of Blender when they might fail. That about covers the basics of a typical QC process for 3D tracking. We looked at rendering previews, we looked at the lens distortion workflow, and we looked at exporting our work to other applications. After watching this series of videos, you should now be able to do a basic track, build some proxy geometry, and export your shot to other software. If you have any specific questions, please leave them in the comments. You can also check out the Boris Effects Discord or the Boris Effects web forum. Once again, thanks for watching. This concludes this series of intro tutorials for SynthEyes. So if you haven't checked out the previous videos, please look for them on this channel. And subscribe to this channel to be the first to watch future videos. And to learn more about SynthEyes, go to the Boris Effects website at boriseffects.com.